Welcome to another AWS Certified Solution Architect Associate Exam question answer session. This is a series of short video where we walk through a couple of practice questions for the AWS Certified Solution Architect Associate Exam. Watch this video to get an idea of what to expect in the exam and follow along share thoughts process on how to work out which answer is correct or incorrect. Let's start. First question. The company is looking to store their confidential financial files in Amazon which are accessed every week. The architect was instructed to set up the storage system which uses envelope encryption and automates key rotation. It should also provide an audit trail which shows who used the encryption key and by whom for security purpose. So, which of the following should the architect implements to satisfy the requirement in the most cost-effective way? Select 2. And options are use Amazon S3 to store the data. Second option, Amazon Certificate Manager. Third option, use Amazon S3 Glacier Deep Archive to store the data. Option 4, configure server-side encryption with AWS KMS Managed Key SAC KMS. Next option, configure server-side encryption with customer-provided key SSEC. Last option, configure server-side encryption with Amazon S3 Managed Key SSE3. And answers is first, use of Amazon S3 to store the data, and second option is configure the server-side encryption with AWS KMS Managed Keys SSE KMS. So the explanation given is server-side encryption is the encryption of data at its destination by the application or server that receive it. AWS Key Management Service or AWS KMS is a service that combines secure, high available hardware and software to provide a key management system scaled for the cloud. Amazon S3 used the AWS KMS customer managed key to encrypt customer master key to encrypt your Amazon S3 object. SSE KMS encrypts only the object data. Any object metadata is not encrypted. If you use customer managed CM case, you use AWS KMS via AWS Managed Console or AWS KMS API tool. Centrally create encryption keys. Define the policies that control how keys can be used and audit keys usage to prove that they and being used correctly. You can use these keys to protect your data in Amazon S3 bucket. Here is the diagram. So this is the master key and encrypting and creating data key. And data key is used to encrypt the data file. AWS customer master key is a logical representation of a master key. The CMK includes metadata such as key ID, creation date, decryption, and key state. The CMK also contains the key material used to encrypt and decrypt the data. You can use a CMK to encrypt and decrypt up to 4 KB of data. Typically, you use CMK to generate or encrypt and decrypt the data key, right? That you use outside of AWS KMS to encrypt your data. This is strongly known as a envelope encryption. Mainly, first key used to encrypt the second key, and second key will be used to encrypt the data. You have three mutually exclusive options. Depends on how you choose to manage the encryption keys. Use server-side encryption with Amazon S3 managed keys. Each object is encrypted with unique keys. As an additional safeguard, it encrypts the key itself with a master key that is regularly rotated. Amazon S3 server-side encryption use one of the strong block cipher available, 256-bit Advanced Encryption Standard (AES 256) to encrypt your data. For use server-side encryption with customer master key stored in AWS Key Management Service, similar to SSE S3 but with some additional benefit and changes for using the service. There are separated permissions for the use of CMK that provide added protection against unauthorized access of your object in Amazon S3. SSCKMS also provides you with an audit trail that shows when your CMK was used and by whom. Additionally, you can create a and manage customer managed CMK or use AWS managed CMK that are unique to you, your service, and your region. Use server-side encryption customer provided key (SSEC). You manage the encryption key and Amazon S3 manage the encryption as it writes to disk and decryption when you access your object. In the scenario, the company needs to store financial files in AWS which are accessed every week, and the solution should use envelope encryption. This requirement can be fulfilled by using an Amazon S3 configured with server-side encryption with AWS KMS managed key. Hence, using Amazon S3 to store data and configuring server-side encryption with AWS KMS managed key are the correct answer. Using Amazon S3 Glacier and configuring the server-side encryption with the customer provided key and Amazon S3 managed key options are incorrect. Next question. A financial firm is designed in an application architecture for its online trading platform that must have high availability and fault tolerance. Their solution architect configured the application to use an Amazon S3 bucket location in the US East 1 region to store large amount of intraday financial data. The stored financial data in a bucket must not be affected even if there is an outage in one of the availability zone or if there are regional service fail. What should be the architect do to avoid any costly service disruption and ensure data durability? Options are: create a lifecycle policy to regularly backup the S3 bucket to Amazon ETL. Option 2. Create a new S3 bucket in another region and configure cross-account access to the bucket location in US East 1. Third option. Copy the S3 bucket to an EBS-backed EC2 instance. Enable cross-region replication. Explanation: in this scenario, you need to enable cross-region replication to ensure that your S3 bucket would not be affected even if there is an outage in one of the availability zone or a regional service fail in US East 1. When you upload your data in S3, your objects are redundantly stored on multiple devices across multiple facilities within the region only. When you create a bucket, thus if there is an outage on the entire region, your S3 bucket will be unavailable if you do not enable cross-region replication, which should make your data available to along region. Note that an availability zone is more related with Amazon EC2 instance rather than Amazon S3. If so there is any outage in Egypt, the S3 bucket usually not affected but the only EC2 instance depends deployed on that zone. Hence the correct answer is enable cross-region replication. The closest options are: create a new S3 bucket in another region and configure to cross-account access to the bucket location in US East 1 is incorrect because cross-account access in Amazon S3 is primarily used if you want to get access to your object to another AWS account, not just to another AWS region. For example, account main array can be grant another account queue permission to access its resources such as buckets and objects. S3 cross-account access does not require data from one region to another region. A better solution is to enable cross-region replication instead. Next question. The company plans to develop a custom messaging service that will also be used to train their AI for an automatic response feature, which they plan to implement in the future. Based on the research and test, the service can receive up to thousands of messages a day, and all of these data are to be sent Amazon EMR for future processing. It is crucial that none of the messages are lost, no duplicate are produced, and they are processed in EMR in the same order as they arrive. Which of the following options can be satisfied a given requirement? Options are: set up and default Amazon SQS queue to handle the message, set up Amazon SNS topic to handle the message, create a pipeline using AWS data pipeline to handle the message. Last option, create an Kinesis data stream to collect the message. To implementation requirement that the chosen AWS service should fulfill is that the data should not go missing, there is durability and stream data in the sequential of arrival. Kinesis can do the job just fine because of its architecture. A Kinesis data stream is set of shard that has a sequence of data records, and each data record has its sequence number that is assigned by Kinesis data stream. Kinesis can also easily handle the high volume of messaging being sent to service. Amazon Kinesis data stream enable real-time processing of streaming big data. It provides ordering of record as well as the ability to read and write or reply the record in the same order to multiple Amazon Kinesis applications. The application, the Amazon Kinesis client library KCL deliver all record for a given partition key to the same record processor, making it easier to build multiple applications reading from the same Amazon Kinesis data stream. For example, to perform continuing aggregation and filtering. So incorrect answers are use of Amazon SQS default queue to handle this message. It is incorrect because although SQS is a valid message service, it is not suitable for scenario where you need to process the data based on the order they were received. Take note that default queue in SQS is just standard queue and not a FIFO queue. FIFO queue stands for first in, first out queue. In addition, SQS does not guarantee that no duplicate will be sent. Next question. A company needs to integrate the Lightweight Directory Access Protocol (LDAP) directory service from the on-premise data center to AWS VPC using IAM. The identity store which is currently being used is not compatible with SAML. Which of the following provides the most valid approaches to implement the integration? Option 1. Develop an on-premise custom identity broker application and use STS to, to issue short-lived AWS credentials. Option 2. Use an identity IAM policy that references the LDAP identifies and AWS credentials. Third option, use IAM role to rotate the IAM credential whenever LDAP credentials are uploaded. Last option, use Amazon single sign-on service to enable single sign-on between AWS and your LDAP. Explanation: if your identity store is not compatible with the XML, then you can build a custom identity broker application to perform similar function. The broker application authentication users request temporary credential for user from AWS and they provide them to use to access AWS resources. An application verification that verifies that the employees are signed in to the existing corporate network identity and authentication system, which might be use LLAP, Active Directory, or any other system. The identity broker application then obtains temporary security credential for the employee. To get the temporary security credential, the identity broker application calls either assume role or get federation token to obtain temporary security credential. Depending on how you want to manage the policies for user and when the temporary credential should expire, the call return temporary security credential consisting of an AWS access key ID, a secret access key, and a session token. The consists of AWS access key and secret access key. Identity broker application makes the temporary security credential available to the internal company application. The app can then use the temporary credential to make calls AWS directly. The app cache the credential use their application expire and then request a new set of temporary credentials. Other options using an IAM policy that refers the LDAP identifiers and AWS credential is incorrect because using an IAM policy is not enough to integrate your LDAP service to IAM. You need to use SAML, STS, or a custom identity broker. Use AWS single sign-on service to enable single sign-on between AWS and your LDAP is incorrect because scenario did not record SSO, and in addition, the identity store that you are using is not SAML compatible. Last option, using IAM role to rotate the IAM credential whenever LDAP credentials are uploaded is incorrect because manually rotating the IAM credential is not optimal solution to integrate your on-premise VPC network. You need to use SAML, STS, or other custom identity broker. A company will deploy an online enrollment systems database on prestigious university, which is hosted in RDS. The solution architect is required to monitor the database metrics in Amazon CloudWatch to ensure the availability of the enrollment system. What are the enhancement monitoring metrics that Amazon CloudWatch gathers from Amazon RDS database? Increase which provides more actual information. Select two. Variable memory, OS processing, RD style process, CPU utilization, database connection. Amazon RDS provide metrics in real time for the operating system that your DB instance runs. You can view the metrics of your DB instance using control or consume the enhanced monitoring JSON output from CloudWatch log in a monitoring system such as you choose. CloudWatch gather metrics about CPU utilization from the hypervisor for a DB instance. An enhanced monitoring gathers its metrics from an agent on the instance. As a result, you might find difference between your measurement because the hypervisor layer performs a small amount of work. The difference can be greater if your DB instance uses smaller instance classes because then there are likely more virtual memories that are managed by hypervisor layer on a single physical instance. Enhanced monitoring metrics are useful when you want to see how different processes or threads on DB instances using CPU. In RDS, the enhanced monitoring metrics shows in the process list you are organized as follows. RDS child process shows a summary of the RDS process that support the database instance. For example, Aurora for Amazon Aurora DB cluster and MySQL for MySQL DB instances. Process thread appears nested beneath the parent process. Process thread shows circulation only as and other metrics are the same for all threads for the process. The console displays the maximum 100 processes and threads. The result are combined of the top CPU consumed and memory consumed process and threads. If there are more than 50% and more than 50 threads, the console displays top 50 consumers in each category. This display helps you to identify which processes are having the greater impacts on the performance. RTS process shows a summary of resources used by RTS management agent, diagnostic monitoring process, and other AWS processes that are required to support RTS database instance. OS process shows summary of the kernel and system processes which generally have the minimum impact on performance. So CPU utilization, database connection, and prevailing memory are incorrect because these are just the regular items provided by the Amazon RDS matrix in the cloud version. Remember that this scenario is asking for enhanced monitoring matrix. A solution architect is designed a monitoring application which generates audit logs for all operational activity of your company cloud infrastructure. Their IT security and compliance team mandate that the application retain the log files for 5 years before the data can be deleted. How can the architect meet the above requirement? Store the audit log in EBS volume and then take EBS snapshot every month. Store the audit log in Glacier Vault and use the vault log feature. Store the audit log in EFS volume. Use the network file system version 4 for logging mechanism. Store the audit log in an emergency bucket and enable multi-factor authentication on the C bucket. And the correct answer: store the audit log in Glacier Vault and use the vault log feature. Amazon S3 Glacier Vault can have one resource-based vault access policy and one vault log policy attached to it. A vault log policy is a vault across policy that you can log using. Vault log policy can help you enforce regularly and compliance requirement. Amazon S3 Glacier provides a set of API operations for you to manage the vault log policy. As an example of vault log policy, supports that you are required to retain Azure for 1 year before you can delete them. To implement this requirement, you can test this policy before locking it down. After you lock the policy becomes immutable. For more information about the locking process, see the Amazon S3 Glacier folder. If you want to manage other user permissions that can be changed, you can use Vault Access Policy. Amazon S3 Glacier supports the following archive operations: upload, download, and delete. Archives are immutable and cannot be modified. Hence, the correct answer is to store the audit log in Glacier Vault and use the vault log. Storing the audio log in Amazon S3 bucket and enable multiple authentication is not correct. A media company needs to configure an Amazon S3 bucket to save static asset for the public-facing website, which method is ensured that all the to uploads the file uploaded to the S3 bucket can be read publicly all over the internet. For that, option 1. Create an IML role to save the object inside the S3 bucket. Policy read. Option 2. Do nothing emergency objects are already public by default. Option 3. Grant public read and access to the object when upload it using a S3 bucket. Configure the ACL of the S3 bucket to set the object to be probably readable and writable. Last option. Configure the S3 bucket policy to set all objects in public reading. Explanation. By default, all Amazon S3 resources such as bucket objects and related sub-resources are private, which means that the only AWS account holds the holder that created it has access to the resources. The resources owner can only grant access permission to others by writing an access policy in S3. You also set the permission of an Amazon object during the upload to make it publicly public. Amazon S3 offers access policy option broadly categorized as resource-based policy and user policy. Across policy, you are attached to your resources and refer to a resource-based policy. For example, bucket policy and access control list are resource-based policy. You can also attach the access policy to user in your account. These are called user policies. You may choose to use resource-based policy, use policies, or some combination of those policies. You may choose user resource-based policy, user policy, or some combination of other of these of the managed policy to your Amazon S3 resource. You can also manage the public permission of your object during the upload. Under the manage public permission, you can grant the read access to your object to the public for all the files that you are uploading to granting public read access is applicable to a small subset of use causes such as what buckets are used for websites. So here is the correct answer. Grant public read access to the object when uploading it using the S3 console. Configure the S3 bucket policy to set all objects to public read. An organizational plans to use an Amazon Direct connection to establish a dedicated connection between its on-premise network and AWS. The organization needs to launch a full managed solution that will automate and accelerate the replication of data to and from various AWS services. Which of the following solutions would be recommended? Use a data sync agent to rapidly move the data over the internet. Option 2. Use a data sync agent to rapidly move the data over a service endpoint. Use Amazon Storage Gateway, Tape Gateway to store data on virtual tape cartridge and asynchronously copy your backup to AWS. Use an AWS Store Gateway for gateway file gateway to store and retrieve file directly using SMB file system protocol. Explanation: AWS data sync allows you to copy large datasets with a million of files without having to build custom solutions with open source tools or license and managed expensive commercial network acceleration software. You can use data sync to migrate active data to AWS, transfer data to cloud for analysis and processing, achieve data to free up on-premises storage capacity, or replicate the data to AWS for business continuity. And AWS data sync simplifies, automates, and accelerates copy of large amount of data to and from AWS storage service over the internet. AWS Direct Connect data sync can copy data between network files, server managed messaging blocks, SMB files, and self-managed object storage or AWS Snow. And Amazon Simple Storage Service, and Amazon EFS file system, and Amazon FSS Windows file system. You deploy an AWS data sync agent to your on-premise hypervisor or an Amazon EC2 to copy the data to or from an on-premise file server. You download the agent virtual machine images from AWS console and deploy to your on-premise VMware, Linux kernel-based virtual machine, or Microsoft hypervisor to copy the data to or from in and out cloud file service. You create an Amazon EC2 instance using data sync agent AMI. In both the cases, the agent must be deployed so that it can access your file server using NFS, SMB protocol, or Amazon S3 API to set up transfer between your AWS Snowcon device and AWS storage. Use datasync agent AMI that comes pre-installation on your device. Since the scenario plans to use the AWS Direct Connect for private connectivity between on-premise and AWS, you can use datasync to automate and accelerate online data transfer to AWS storage service. The AWS datasync agent will be deployed to your on-premise network to accelerate the data transfer to AWS. To connect automatically to an AWS service, you need to use a direct connect service endpoint. A company has a high performance CPU (HPC) clustering that is composed of EC2 instances with provisioned IOPS volume to process transaction-intensive, low-latency workload. The solution architect must meet high IOPS while keeping the latency down by setting the optimal queue length for the volume. The size of each volume is 10 GB. Which of the following is the most suitable configuration that the architect should set up? Set up the IOPS to 800, then maintain the low queue length. Set up the IOPS of 400, then maintain the low queue length. Set up the IOPS to 500, then maintain the low queue length. Set up the IOPS of 600 and maintain high queue length. So the expression is provision IOPS SSD volumes are designed to meet the need of IO-intensive workload, particularly database workload. They are that are sensitive to storage performance and consistency. Unlike GP2, which use a bucket and credits mode to calculate the performance, and IO1 volume allow you to specify the consistent IO/provision IOs. Performance 99.9% of the time over a given year. An ion one volume can be ranged in size of 4 GB to 16 TB. You can provide provision from 100 hours to 64,000 hours per volume on Nitro system instances handling and up to 32,000 on other instance handling. The maximum rate of provision IOPS to request volume in GB is 50 is to 1. For example, an 100 GB volume can be provisioned with 5,000 IOPS on supported instance type. Any volume of 1280 GB in size or greater allow provisioning up to 64 IOPS, maximum of 15 to 1280 GB. An IO volume provision up to 3200 to 2000 IO supported or a maximum IO size up to 56 kb and yield as much as 500 MB of throughput, which the IO size at the maximum. Peak throughput is reached at 2000 IOPS. A volume provision with the more than 32,000 IOPS up to the cap of 64,000 IOPS support a maximum size of 60 kbs and yield as much as 1000 megabits per second throughput. The volume queue length is number of pending I/O requests for the device. Latency is through end-to-end client time of I/O operation. In other words, the time elapsed between the send and I/O to EBS and receiving an acknowledgement from EBS I/O. Read or write is completed. Queue length is must be correctly capable with I/O size and latency to avoid creating bottlenecks either on the host operating system or the network linked to EBS. Optimum queue length varies from each workload depending on your particular application sensitivity to IOs and latency. If you work in not delivering enough I/O requests to fulfill your performance available to your EBS volume, then your volume might not deliver the I/O or throughputs that you have provisioned. Transaction-intensive applications are sensitive to increased I/O latency and are well suited for SSD-backed I/O and GPU volume. You can maintain high I/O while keep latency down by maintaining a low queue length and high number of I/O available through volume, constantly driving more I/O to a volume than it has available can causes increased I/O latency. Throughput incentive applications are less sensitive to increase the I/O latency and are well suited for hard disk backing. External AC1. You can maintain a high throughput of hard disk backend volume by maintaining a high queue length of performance sequence. Therefore, for instance of 10 GB volume can be provisioned with the 500 IOPS of any volume of 640 GB in size. Greater allow provision up to maximum of 32,000 IOPS, 50 into 640 GB. Hence, the correct answer set is IOPS to 500. Then maintain a low queue length. A multinational company with a multiple on-premise data center around the globe is heavily using AWS to serve the clients worldwide. The company already hundreds of VPCs and multiple AWS connections to their data center. That's been to multiple AWS regions. As the number of workloads running on AWS grows, the company must be able to scale its network access, multiple accounts, and Amazon VPC to keep up. A solution architect is takes to interconnection all of the company's on-premise network, VPNs and VPCs in a single gateway. That includes support of inter-region peering across multiple database regions. Which of the following is the best solution? Tech architect should set up to support the required interconnectivity. These are the options, and the final option and question answer. Correct answer is set up an AWS transit gateway to implement a hub and spoke network topology in each region and route all the traffic through the network transit center. Route traffic between VPCs and on-premise data center over the AWS site-side VPN.